Hi and welcome back to another Æther Physics. In my last video I was working on water. I showed you how water has magnetic properties or anti-magnetic properties. And I was searching for some information on the internet and I stumbled upon a paper. So it's about water absorbing heat energy from sunlight or from a light source. What they did was they magnetized the distilled water for 24 hours with a magnet of 0.1 Tesla. That's the strength of the magnetic field. They tried it with two poles, the north pole and the south pole of the magnetic field. The conclusion was that there was an opposing effect on the poles. For this experiment, they used a spectrophotometer, which is a machine that can check on different wavelengths of light. The spectrophotometer that they used was between 340 nanometers and 1000 nanometers. The conclusion they made, which I have drawn here, we're talking about light. So let me explain a little bit. We've got over here on the left, we got UV light, from purple UV, that's 340 nanometers for a wavelength of light. On the right, we have 1000 nanometers, which will be infrared. And between the vertical lines is the spectrum that our eyes can see. 340 nanometers, which will be UV, 400 nanometers will be purple, 460 blue, 520 is green, 580 yellow, 640 will be orange, 700 nanometer will be the red color. Everything with a longer wavelength is infrared. Water is an important liquid here on Earth. Not only for us humans to drink, but also for biological and medical studies. And water is the main absorber of sunlight on the planet Earth, and mainly in the infrared. An interesting fact about water. We need to know more about the molecular structure of water. We all know that water is H2O, which means that there are two hydrogen atoms and one oxygen atom in it. The hydrogen atom was an hydrogen ion, which means that it is a plus, it has a plus electron, it's a negatively charged atom. A fun fact to know about the water molecule is the angle in degrees is 105 degrees between the two hydrogen atoms. In liquid water, when the temperature is rising between the temperature of 2 degrees Celsius and 85 degrees Celsius, the molecular stretch vibrations shifts to a higher frequency. What are the stretching vibrations? The H2O molecule. There are certain types of vibrations. There are stretching vibrations. You can have a symmetric stretching vibration and you can have an asymmetric stretching vibration. And what this says is that the higher the temperature, the faster the vibrations would be on the hydrogen atoms connected to the oxygen atoms. And we have bending vibrations. And they have different names. We can have a scissoring, and we call it a scissoring when it is in plane. Imagine these two pens as that molecule. What we mean with in plane scissoring is that it is in plane. If it's not in plane, we call it wagging, which means it's more like this. So they're not in a plane scissoring, they're wagging. And rocking would be this movement. If they're off plane, it will be twisting. An interesting fact about the water molecule is that the sum of the positive charge of the nuclei, so that will be the positive of the protons and the neutrons within these atoms, the center of the positive charge is not equal to the center of the negative charge. What that means is that you have a dipolic effect on the molecule of water, and that's why it reacts to a magnetic field. What was one of the conclusions that they had on this experiment? The absorption of the spectrum of light increases when you use a north pole on the distilled water. So you have distilled water, you have a north pole, and you magnetize the water, and if you use a north pole, it increases the absorption of the spectrum of light. If you use a south pole, it seems to decrease the absorption of the spectrum of light. If you look at this graph again that I've drawn here, I've drawn a black line in the middle, and on top of the black line I drew a red line which represents the North Pole and the amount of absorption on the water. So when you use a North Pole on distilled water for 24 hours, then that increases the absorption of radiation, which means that the frequencies of the stretching vibrations would gain which means that the temperature would rise. And the conclusion is that if the temperature is rising, then the density of water increases too. And if you use a south pole on the still water, then that means there is a lower amount of absorption of the radiation spectrum, which means that the frequency is less rising than it would with a north pole on the stretching vibrations, and that decreases the density of the water. The lower the density of water is, the more fluid the water is. The more fluid the water is, the greater it is for biological activity. So in conclusion, the magnetic fields change the density of the water. The North Pole increases the density, and this due to an increasement of absorption, and the South Pole decreases the density, and that is due to a lower absorption of radiation. It's all about the quantum mechanical absorption of light on atoms. We're not going to go into quantum mechanics. Maybe we can do it. If you guys are interested, I can explain some interesting things about quantum mechanics, because it's a very interesting topic and I know a lot of quantum mechanics. As you all know, I'm trying to create an Æther Physics, which means that we try to translate the laws of the classical physics and the modern physics, the quantum mechanics, and try and translate it in a way that we can fuse it in an ether. So that means that we need to use a relativity theory of Albert Einstein, and we need to use the photoelectric effect of Albert Einstein and somehow mix it together. Because the photoelectric effect of Albert Einstein was the beginning of quantum mechanics. The photoelectric effect is all about that energy of light is equal to Max Planck's constant times the frequency of light. We're not going to talk about quantum mechanics today. We're going to make some videos about that topic and try and translate it in a way that we understand it, in an ether way. A monochronic radiation means it is a radiation of one frequency. A laser is, for instance, a monochromic radiation. A light bulb would not be monochromic because it has different colors together, but a laser only has, for instance, a red laser would only have 700 nanometers. And a green laser would have 520 nanometers. And I have a green laser somewhere here at home. And lasers are monochromic. So only one frequency comes out of the light source. So if monochromic radiation of the intensity of I on the absorbing medium called X, the loss of the intensity is proportional to I and the delta of X. We can change this in a formula, and that formula would be delta I, and delta means the difference, is equal to mu. Mu would be our absorption coefficients. I'm going to write it down. Absorption coefficients times the intensity times the delta X. We changed our conclusion of the loss of intensity is proportional to I and delta X into a formula that we can use. Now we're getting to differentiation. If we would make delta X almost as small as 0, so it's going towards 0, so we want to have a differential of this formula. When delta X is getting close to 0, we can write this formula in a different formula. It will be di divided by dx is equal to minus mu times I. And with integration, we can change this formula into I equals I0 times exponential of minus mu times x. Y'all know I'm more about theoretical physics than about practical physics. We can rearrange this formula here. If we would say that d is the optical density, then we can define for practical customer d as d equals natural logarithmic of the I0 and I. I think that was all that I saw in the paper. The link to the paper will be in the video or in the description. An interesting fact, huh? I hope this was interesting for you all guys. I hope you've learned something new today. And if you're new to the channel, please subscribe. I make these videos every once in a while. It would mean a lot to me if you would subscribe. Thank you all for watching and see you guys next time. You know what's going on, man. Yo, thanks a lot. Yo.